So for planes, you need to look at, we are looking at, so like I say, right, two skew line we know. So now we are looking at the point on the plane. So deduce a random point on the plane, shortest distance. All these are very important stuff. So we quickly do the rest lah, just to recall. So the first one is between a point and a plane. Deduce a random point on the plane. Now this is important. Okay, let's first one. You have to find the shortest distance from a point A to plane, right? So this is A. This is 3, 1 minus 2. P1 is R dot 1 minus 3, 2 equals to negative 5. Okay. So what we need now is essentially draw this normal out here. This is a normal equation. Is 1 minus 3, 2. Always change in scalar product form. So if you've forgotten how to change it, this is 1 minus 3, 2, the normal. The normal is 1 just take the coefficient. Because that is just a dot product lah. That's just a dot product, right? So that's the normal there. Then find the exact shortest distance of point A to plane 1. Okay, now any kind of distance you need to use magic triangle. So we mentioned that before. You can't do this magic triangle when you don't have a point here, right? You have to find a point here. That's the idea there. Then what we get is you need to guess a point on the plane. So always guess a random point on plane. So just let Q be a point on plane. Any point will do. So how do we guess? This is a plane, infinitely many. Any combination of x, y, z, which satisfy the plane one will be on the plane. So just remember that any combination. Guys, when I say any combination which satisfy this equation, it's not, please read it as a full sentence. It's not any combination of x, y, z. It's any one x combination of x, y, z which satisfy the equation. So you give me any x. So let's say 5, 0, 0. Negative 5, 0, 0 will be on the plane because I put minus 5, minus 3, 0, plus 2, 0. Definitely will be minus 5. This will satisfy the plane equation. You can also use so any combination. So any combination. So remember that you can be negative 5, 0, 0 because I know x, y, z here will satisfy it. You can also be negative 2, 1, 0. It can also be 0, 1, negative 1, and so on. Okay, the list goes on. So I'm going to let, of course, I can pick any number. So I'm going to let Q be Q. I just use 0, 1, minus 1. Be a point on plane. Okay, so just let Q be this 0, 1, minus 1. Then once you found a point which is on the plane, which satisfies the plane equation, what you do now is just use magic triangle. Always know that magic triangle is there to help you to find shortest distance. You find this is QA. This is QA, right? Okay, you have QA already. So it's not surprising to you that you can actually find the shortest distance now because you have the normal vector. This is theta. So you're finding adjacent side. If you're finding adjacent side, this over here is dot product. Because cosine is dot product, right? Cosine is dot product. So AQ dot with n. Then modulus. Modulus because you want to find the length, so it's modulus. Then you unit vector the n. You don't unit vector the hypo. Remember not to unit vector the hypo. Okay, so this is AQ. So hence, shortest distance of A to P1 AQ unit vector. Let's do this. So A to Q, we can find it. A to Q will be just 0 minus 1, 3, 1 minus 2. That will be minus 3, 0, and 1. So this will be minus 3, 0, 1 dot with normal vector, which is 1 minus 3, 2. 1 square plus 3 square plus 2 square. Do the dot product. minus 3, 14. So this will be 1 over square root of 14 units. So this is the first. Now, once done already, so the other one is also if you have a point and a plane, you need to know how to find the foot of perpendicular. Okay. Foot of perpendicular is important. So let's just, so you see for one concept here, we have to know how to deduce a point in the plane, and then we slowly move forward lah. So part 2, let's look at how to find a foot